Hi, and welcome to day 12 of Just Start Programming, creating console terminal apps using Rust and Ratatouille. Today, let's cover how we can do testing or the test-driven development of Ratatouille. And if we have enough time, we'll start looking into the recipes for developing applications, such as command line arguments, configuring directories, and let's see how far we can go. Join me once again live in one take, no shortcuts and no secrets. So let's just start programming. Alright, so welcome back. So for today, let's go through the test-driven approach of Ratatouille. Okay, so let's start with testing apps. Testing apps. Testing with Insta snapshots. Okay, what do we have here? So snapshots tests allow you to skip the tedious process of writing exact tests by capturing reference values once, and then using them in all future test runs. It's easy to use Insta and Cargo Insta to write snapshot tests for Ratatouille apps and widgets. How do we start? First, make sure to install Cargo Insta and include the Insta crate in your Cargo tunnel. So let's do this one. I think it doesn't matter where you are, or does it matter? Cargo install. Okay, so this one is like the cargo generate. Okay, the next Instacrate in your cargo tunnel. Okay, so we're already here inside Hello Ratatouille. Let's check cargo tunnel. We don't have Insta here. So if we add Insta -- dev. Nothing changed. Cargo add Insta -- dev. That's what I did. Okay, creates that IO index. dev dependencies. Run the following cargo command in your project directory, add insta, or add the following line to cargo.toml. That's what I thought, cargo add insta. The only difference is this dash dash dash. It's not here. So where did it go? Let's try to search cargo. No. They are not included when the package is built for release or when it's used as a dependency by other packages. Okay, so there will be dev dependencies. Sample Ratatouille. Oh, I mean hello Ratatouille. Okay, my mistake. Sample Ratatouille. Cargo and insta dash dash dev. Okay, so now it's here. I was in the wrong project earlier. Okay, so next, structuring your application. Let's assume you have a simple application that implements the abstract, which is responsible for your TUI's core logic and rendering. To test this with Insta snapshots, you use a test backend from Ratatouille to capture the output in a test environment. Derive default struct app widget for app. Widget for app. Implement the widget trait. Okay, and then in test, super app, test vendor. Terminal, draw, frame. Okay, so what can we do here? Maybe let's try one simple widget. Let's see first what shows up here. Okay, we don't want that. Let's see. Frame count widget. Or maybe we can use frame count widget. Frame count widget, and we know it's going to be 1. Yeah, maybe we can use that one. So what do we need to do? Need to include this derive default. Okay, let's get back to frame count widget. first step. Next is you will create test. So test, we can just put it all the way here below. With this compile. Choose app, widget is not satisfied. Okay, so it shouldn't be app. Test render app default. Okay, so instead of app, frame count widget. Okay, so why does it complain? Required for frame count widget to implement widget. Count widget. Frame count widget. Okay, so frame count widget is stateful widget. Let's use another one. About my widget. My widget. Hello world. And then here, let's change it to my widget. Okay, what's wrong with this? Okay, so now I think we can compile. Let's see how it works. So we should run the test as cargo test. The output of the terminal draw method will be compared against a snapshot if This is the first time running the test or the output has changed. Instead, we'll create a snapshot file under snapshots directory. For example, after running the test, a new snapshot file might be created. Okay. This file will store the visual representation of your terminal as string. Let's run this first. Cargo run. Let's see how it looks. So hello world, very simple. If we do a cargo test, let's inspect first. GitHub VS Code source. So where can we find the snapshots? Snapshots. Cargo test. Let's see. Oh. New result. Did it do? Panicked. Okay. Also, there's a snapshot directory. Source, assertion, expression. There's no hello world here. Okay, so something is wrong. Test backend 8020 unwrap terminal draw frame render widget app. My widget. Oh wait, I think my widget will have this one. Content string from hello world. Okay, so let's copy this. Copy. Should it be like this? That app. My widget. Should it be like this? Cargo test. Okay, so hello world is there. Test result failed. One failed. Okay, so it failed. When did it fail? 8020. 8020. Is that relevant? Okay, this file will store the visual representation of your terminal as string. That's what we have here. Terminal as string. In the snapshot, each line represents a row of the terminal capturing the rendered state of your TUI. The next time you run your test, the output will be compared to this file to detect any unintentional changes. Oh, assertion with colors not supported as of now. Okay. Yes, I think we have, it was green. That was green. How about if we just have the default? Style default, no color. Cargo test. Okay, so it still failed. When changes to the are intentional, you can update snapshot by running cargo insta review. Okay. Uppercase A, R, and S to apply to all remaining snapshots. How about if we accept this one? Accept. A. And okay, hello world. And cargo test. It's okay, one passed. Okay, so that's how it works. So it says that color is not supported. So let's try this. Oops. So it should pass. Yeah. So that one is still okay. But if we change it to this one, I'm just curious. So what if there's no hello world here? It's default. Will it pass? What's this line? So there's a minus, so it's like diff old snapshot, new results. Okay, so test-driven development. Wanted to display hello world. So that's the expected. So it's being compared to this one from the snapshot. But who is creating the snapshot? Is it this one? Say for example, I want this to be hello world. I mean, if this is the expected. Okay, and then we do this one. So hello world. And Insta review. Cargo Insta review. So what happened to this? So if this is expected, then if we do a cargo test, it will still fail. Oh, why did it pass? Why did it pass? Because here it's hello world. I am a bit confused. So we're testing the widget, but we're putting in here how it should look. Hello world. But it is recording this in snapshot. Okay, so we are recording that in snapshot. This command allows you to review the differences and accept the new snapshot if desired. If your UI changes often, consider reviewing the snapshots after significant updates to avoid constant failures in CI/CD pipelines. Use consistent terminal size 80 by 20 in this example to ensure reproducible results. 80 by 20. The old terminals, was it 80 by 20 or was it 80 by 25? I think it was 80 by 25. Those terminal rows and columns. Yeah, it's 80 by 25. 80 by 25. Those about Unix. $80 by 24. Historically, the normal size for a terminal was 80 columns by 24 rows. Okay. It's good to know. Anyway, consistency is important point here. So if we accepted this, I mean this is the expected, so it will record the output. Okay, so it could be that in between when the program runs, it could also change. So this is a way where capture the snapshot as the intended output first. So you accept it should be this, and then you run it again and it's being compared against this one. Okay, so that's good to know that can do test-driven development in Ratatouille using snapshots. And then let's move on to debugging widget state. Debugging widget state. Debugging widget state in a Ratatouille application can be challenging as the Ratatouille takes over the terminal. So your usual debugging tools like printline and debug macro won't work as expected. However, you can still debug your widget state effectively by writing logs to a file or using TUI logger. TUI logger. Logger with smart widget for the Ratatouille crate. Demo of the widget. What does it do? Okay, sometimes though you might want to inspect the state of a widget or some application value directly in your terminal. You can do this easily by rendering the debug text of the widget or value somewhere useful and providing a way to toggle it on and off. This is especially useful for development and debugging purposes. The following code shows how you might implement this for some simple form state. More advanced applications may want to have more sophisticated debug views. The principle remains the same. The app state has show debug field that can be toggled on and off. And the render function allocates some space to render the debug information when show debug is true. Demonstrates how to debug widget state in Rust applications by showing a debug view of the state. It's a long piece of code. Let's see. Okay. So you have this. You have main, init and restore, then run. So this is where you have the loop. Okay, run. The loop is here. Terminal draw frame. Event read key. Event kind press. You press Q. Okay, return okay. T debug. Okay, so I think we're more interested on this part. Show debug. Render. State. App state. Widget form. upstate, 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 show debug bool. Okay, debug with render widget state, state, okay, upstate form, upstate form, no, upstate form. If state show debug text. Format render widget. Okay, so it's just rendering content. Yeah, so yeah, this one, it's rendering content. Yeah, so it will show this one, state, upstate, but here does it show this? The widget debug. Debug is from here. Let's try this. Cargo debug state. Let's see. Building. Cargo run. So what do we need to press? D. Shows up. Q. So what happened here? Run terminal. Okay, so run It goes in here. You have app state default state, terminal draw frame state, app state, and then render form as a widget. Oh, it has the ampersand here. Render layout vertical. So you have two, so left and right. Name age. There it is. Name age. Okay. Name age. Format name, self-name, render name age. Render. Okay, so we're rendering the form as a widget. So it goes inside this. Draws the current state of the widget in the given buffer. That is the only method required to implement a custom widget. Okay, because it's a custom widget. Then here, if you press D, show debug, state show debug. State show debug is equal to, okay, so not, so it's a toggle. Okay, toggle debug field. Show debug. It toggles on and off. Okay. But what will happen if okay, so this render is actually calling this one frame, and this one is the app state. Okay, so that's why you have the percent here. Debug with from state debug. Show debug. Show debug. Why is it U16? Show debug is Boolean. Converts this type from the input type. So Boolean to unsigned 16. Then constraint field 1, constraint field, okay. So here the debug with horizontal, layout horizontal. So horizontal, left to right, then you have 2. Render widget. Render widget, rendering which one? State. Form. Rendering widget, state, form. Okay, so it's rendering this form. App state form. App state. App state form. app state form. So it will render app state form. So it will render this form widget. Okay. If state show debug text from debug text. Okay. So this is the right portion because you have debug here. Yeah. You have two rectangles. Main is the one at the left and then debug at the right. So it checks for show debug. If you press D, you'll toggle it on and off. Then show debug is true, then this one will be rendered. Okay, so if we disable this, then of course it will not show up whether you press D or not. Try it again. D. Yeah, it shows nothing. Okay. Yeah, so it's just basically showing pretty formatting here. It's formatting the content of the state. State is app state. App state will have this one and the form. So the form is included. So it will do a breakdown of the form itself. It will expand it to form. Okay. Okay, so that's how you do it. You're doing it manually to show the debug. Then, yeah, you're occupying space also in your view. Yeah, but you can have this rendered also somewhere below. All right. Then let's start with develop applications. Okay, so here it says this section covers recipes for developing applications. CLI command line arguments. Okay, configuration directories. Okay, so you have logging as well and tracing. Arrange your app code. This is maybe creating modules or components. Maybe panic hooks. So error handling. Use better panic. Yeah, so it's still part of error handling. Migrate from TUIRS. TUIRS. Okay, I don't know yet. Spawn VM. Spawn VM. From terminal, maybe you can create a open up Vim. Releasing your app. Okay. So maybe Vim, maybe it does Vim. No, VI. Maybe it does that. Okay, let's see. I don't know if we can cover everything, but once we are done with that, what else is here? Highlights, release notes, showcase, templates. Oh, templates is an interesting topic as well. References. Okay, so let's continue. Perhaps after these things, we can create an application. Yeah. Okay, so that would be the target. CLI arguments. Command line interface tools often require input parameters to dictate the behavior of what is this? Lab. Command line argument parser. Okay. It's a feature-rich Rust library that facilitates the parsing of these arguments in an intuitive manner. To use the derived syntax as shown in the following snippets, be sure to enable derive feature. That is by running cargo add clap feature derive. Okay. So maybe let's create a new project. Let me close this one. This. Yeah, we're done with this. How should we call this? Cargo. I arguments. So we need cargo add clap feature derive. Add clap. Okay, so that one we'll insert it in the cargo dot. Unexpected argument. A similar argument exists. Features. Okay. So with S. Okay, features. Small typo error. Adding, there's even windows here. Okay, let's check. Tama. Yep. It's added. What does it do? In this snippet, we utilize the clap library to define an args struct, which will be used to capture and structure the arguments passed to the application. Ratatui template with cross term and Tokyo. Okay. Here, the arg struct defines one command line arguments. Uptick rate dictates the application's tick rate. This is supplied with default values, ensuring that even if the user doesn't provide this argument, the application can still proceed with its default. Okay, so the default value is here. So let's try this. Name. Version. Cannot find function version in this scope, not found in scope. Allow Ratatouille. No. Cargo. Okay, version. Oh, version is there as well. So what is it referring to? Cannot find function version in this code. If we cannot find it, then disable it. Okay, then what is this? Main function not found. No. Cargo run. Let's see. We not supply any argument. So this is supplied with default values, ensuring that even if the user doesn't provide, I mean, that's just to illustrate perhaps that you can have this. So let's continue. Displaying version information. One common convention in CLI is the ability to display version information. Here, the version information is presented as a combination of various parameters, including the git commit hash. Version function, as seen in the snippet, fetches this information. Okay. So it means that we need this code, this function, to be here. Edit that. Clap command version. Not satisfied. Okay, so there are so many things missing. Okay, maybe let's just continue and see what is what is missing. Okay, so there's a version function that will return all of these values. Format. Yeah. It's assumed for now that you will get this value. So this function uses the get dir, get config dir from section on xtg config directories. This function also makes use of an environment variable Ratatui template getInfo to derive the git commit hash that can be populated during the build process by build.rs. Okay, print line. Okay, by invoking the CLI2 with the dash version flag, users will be presented with the version details, including the author's commit hash and paths to the configuration and data directories. Okay, so it will look like this. The version function's output is just an example. Easily adjust its content by amending the string template code above. Okay. Here's the full build.rs for your reference. I hit build.rs. Okay, so let's copy this one. Configuring directories. Oh, that's it. That's it. What can we do here? Get config dir. There's so many things that working here. How can we fix this one? The trait bound str from is not satisfied. Following other types implement trait from. What can we do? Maybe comment this out. Comment this out. Just return format version 1.0.0. Oops. required by a bound in clap command version. What does it mean? The following other types implement trait from. This one needs to be changed. This. Required for a CD string to implement into. I have no idea how to fix this. Version. Okay, so how about if I just put it here directly? Version here. Oops. Version here. Okay. Seems to work. Let's try. Cargo run. Cargo run dash dash version. Dash dash. Is it supposed to display this one? Ah, okay, so it's here. But where can we find this? By invoking CLI. Okay, okay. Go to debug. Target debug. So So CLI CLI arguments, CLI arguments dash dash version. The version function's output is just an example. You can easily adjust its content by amending the string template code above. Yeah, of course, we can change it. But okay, about about not but about. I don't know. In this document, it's revision. Cargo package version. Somehow it was able to display some things. Okay, so what do we have here? Git output, git describe, string git describe from cargo package version. Is it somewhere here? Where is this git head, ref head stacks? I don't know. I don't know how to make this work. Cargo clap. Okay, let's see. Cargo clap. Simple program to greet a person. Version about, long about, none. Okay, args. Try it out. I think this one is better. one is way too complex. There. Simple is better. So how do we do this? Demo help. Okay, let's see. So in our case, it's not demo help, but like this. But there. Yeah, this is better. Simple program to greet a person. Okay, options dash dash name. Name of the person to greet. Let's see, dash dash name. Joe. Joe. Okay. Count. Maybe can do something like this and count 3. Ah, this is better. This is more understandable. Short, long, default value. Count. Okay, so you have name and count. So aside from version and help, you have name and count. Then if you add maybe just copy that one. Arg. This short and long. Maybe something to do with the parameter. Description. Something like this. String. Args description. Okay. This is just a marker. Oh. Where's description? Okay, so description is there. I think this is short, this is long. So if we remove long, let's see. Okay. So let's put in the description. Hmm. Oh, it needs the name. D. Dash D. The short form. Okay, there. Okay. Yeah. So, okay, so it's just showing us that, yeah, I mean, if you're building a terminal app, you can make use of command line arguments using this library. Alright, so let's move on to the next one, configuration directories. Setting files and directories correctly in a command line or TI application ensures that the application fits seamlessly into a user's workflow and adheres to established conventions. One of the key conventions on Linux-based systems is the XDG-based directory specification. By the XDG-based directory specification, the XDG-based directory specification is a set of standards that define where user files should reside, ensuring a cleaner home directory and a more organized storage convention. By adhering to this standard, your application will store files in the expected directories, making it more predictable and user-friendly. Using directories -rs for path resolution. The directories -rs library offers a Rust-friendly interface to locate common directories, like config and data directories, based on established conventions, including the XDG-based directory specification. Add directories that are to your cargo toml. Okay. Copy. Okay. Directories. Okay. Use the project dirs struct to retrieve paths based on your project's domain and project name and create helper functions for getting the data dir and config dir. Allows user to specify custom locations using environment variables. This flexibility can be crucial for users with unique directory structures for testing. A good practice is to notify the user about the location of the configuration and data directories. An example from the template is to print out these locations when the user invokes -- version command line argument. See the section for command line argument parsing. Here's an example: get data dir and get config dir functions for your reference. Get data dir, get config dir. Let's copy this part. Directories. Yes. Color. Okay, so this is from Ratatouille. Get data dir and get config dir. Data dir get config dir. Okay, anyway, that one is just a warning. Let's see if it works. Okay, find here. Uh, then what happened? This is another complex example. Okay, so perhaps we'll continue with the rest of the topics here tomorrow. Since hope to see you guys in the next video. Before that, let me thank my sponsors. I mean, supporters.